another example. Suppose we have 2x squared plus 2x equals a negative 1. Okay? So let's bring the quadratic formula to remind ourselves what we need to do. First of all, determine what a, b, and c are, but even before that, we need to put the equation in standard form, which means that everything needs to be on one side. Okay, so 2x squared plus 2x plus 1 equals 2, b equals 2, and c equals 1. In this case, all of the putting that into the formula, we're going to have the solutions for x are going to be minus b plus or minus the square root of b squared minus 4 times a times c, and that is divided by 2a. So the whole thing is divided by 2 times a, in this case 2 times 2. So when we simplify this, because the a happens minus b turns out to be a minus 2 in this case. Minus 2 plus or minus the square root of 4. I have only one negative here, so that's 4 minus 8 divided. But if you are thinking ahead, you probably have realized that the solutions over and that's perfectly fine. We have lots of those quadratic equations with non-real solutions. So we have x equals minus 2 plus or minus the negative becomes an I, the square root of 4 is 2, so this becomes 2I divided by 4. Now, notice that we have an even number here, but each of these is even also divided by 4, and at this point we can go ahead and say into the denominator 2 times. Be really careful about trying to cancel this in the step ahead this 2 with this 4, because this 2 is not a factor. You have to factor it out, then it becomes a factor, and then you can go ahead and cancel it down below. So the solutions then are minus 1 plus or minus I divided by 2. Once again, 2 solutions. We do have an I solution, but it's perfectly fine. Okay. Now, let's continue to work with these. Let's do one more problem. Let's consider 9 a is equal to 9, b equals 12, and c equals 4. All right, let's substitute into the quadratic formula. So the quadratic formula says squared minus 4ac divided by 2a. Right? All right, so the solutions for x, and whatever variable it happens to be, it may not be x. In this case, I did write an x. Plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Substitute into the formula. So what do we get? We're going to have x equals minus 12 plus or minus 104 divided by 18. Well, notice what happens. In this case, the solutions are going to be minus 12 plus or minus the square root of 0. That's just 0 divided by 18. So what we end up with is simply one solution. So when the numbers inside the radical give us 0, the plus or minus disappears, and we have so this number is an important number, the number that's inside the radical. It's important enough that it has a special name. It's called a discriminant. And so notice that with this particular problem right here, 9x squared plus 12x plus 4 equals 0, we have only one solution. That number factors, and we could have solved it that way, perhaps a little bit faster. Notice that if I had plus 4 equals 0, I might have seen that 3 times 3 and 2 times 2 are the factors of 9 and 4, which I need to give me a sum of 12 by cross multiplying. X plus 2 times 3x plus 2 equals 0. Check your work. 2 times 3x is 6x. 3x times 2 is 6x. That gives me a middle term of 12x. We have a 9x squared for the first term, and 2 times 2 is 4. But when you set each of the factors equal to 0, you get the that in this case we could have, if we looked at the quadratic formula, we would have seen that that number inside the radical becomes 0, and in that case we get only one solution. That's important. Let's look at some of the other problems that we did earlier. For example, the problem where we had 2x into the quadratic formula. Notice that the number inside the radical became 4 minus 8. It became a negative 4. And because of that, we ended up with non-real solutions. So radical, we have non-real solutions, and there will be 2 of them, 2 non-real solutions. So we've seen an example of something that gives us only one solution when the quantity inside the radical is 0. If the quantity inside the radical is a negative, we get 2 that we worked on a little bit before. We have 2 real solutions. One of the earlier examples we had was this one, 3x squared equals 5x plus 2, with a number which is a positive number inside the radical. When the number is positive, we end up with 2 different solutions, and in this case 2 real solutions. Okay. In this particular case, it happened to be a perfect square, but that won't always be the case. But the important thing is, if that number is positive, we will have 2 real. Quality, and that is that it can tell us the number of solutions that we have and the kinds of solutions. So this number inside the radical, the number b squared minus 4ac, is called a discriminant. Discriminant. Okay? So let's make a summary of what we have just discovered. If that discriminant, b squared minus 4ac, happens to be greater than 0, then we will have 2 real solutions. If that number inside the radical, the b squared minus 4ac, if that discriminant is less than 0, we will have 2 non-real. And I like to call them non-real solutions rather than complex solutions, because we know that real numbers are also complex numbers. Finally, if that discriminant, b squared minus 4ac, happens to be equal to 0, then we have 1 real solution. So that number b squared minus 4ac, which is called we have. It's an important number. Okay.